Good day everyone, and thank you for joining this presentation. I am Pierre, and today I will talk to you about PlanCurves, an interface for end users to visualize multi-agent temporal plans. This work is a collaboration between the planning research and the visualization research done at the Orca Hub. So we've been looking at multi-agent temporal plans, which are getting more efficient and reliable, but there's still context where human oversight is critical, and we can simply think of a user that has a more up-to-date knowledge of the situation, or perhaps maybe a supervisor that needs to be accountable for the plan safety and success in unpredictable environments. So what we've been asking ourselves really is, how do we present plans to users so that they can carry out this kind of assessment? And we had requirements for this project. Obviously, first we wanted to show the users an overview of the activities to be carried out. And we also wanted to provide users with the ability to quickly detect any interactions between agents, which could be leading to conflicts. The other thing we wanted is to make this planner and domain agnostic, just to be able to account for any change in the future, really. So with that in mind, we first started creating our first visualization, which is simply a Gantt chart or activity chart, showing a familiar way to show activities along a time axis, really. As opposed to traditional Gantt charts, we decided to group the activities by agents, just to provide users with the ability to see the individual missions of each agent through the plan. Where it shows the activities, it fails to show unpredictable interactions between the agents, and that's where we started working on our second visualizations, which are time curves, which is a novel application of this visualization, really. Time curves are simply showing the timeline of each agent throughout the plan, but we also distort these timelines to represent the similarities between states of the agent. So really what you're looking at is, the closer the dots on the visualizations are, the more likely those agents are interacting at this time of the plan. Similarities comprise of multiple dimensions. Obviously we want time, but it can also encompass position, the resources used by the agent, or the type of agent. And once we have these similarities, they are simply scaled to a 2D visualization using a projection algorithm. Next, because our project was environment-based, we wanted to also add support for that. So we first created a scene map visualization, or simulation if you want, which is essentially just showing the movement and position of the robots throughout the plans at selected times. We also put a path planning algorithm inside the system, just to be able to extract the more accurate movements of agents throughout the plan. This is simply using A-star algorithm and Euclidean heuristic at the moment. So how does it work? Initially, we just wanted the users to be able to provide a plan and get the visualizations out of it. However, plans alone are kind of lacking data in detail to be able to provide accurate and efficient visualizations to the users. Informative visualization, really. So we also made the system able to receive interpretation rules to be able to parse the plan and give informations to the user, and also roadmap data, or environment data, just to be able to account for environment-based plans. So the first thing the system does is read the plan and extract the actions from it, and parse these actions to be able to create action data. Mainly an action datum is represented with the name of the action, the actor carrying out the action, parameters that the user wants to keep, a natural language description for the user, and all of the temporal information. This action data is simply used by the Gantt chart to build the visualization, but it is also used in the next phase of the system, where we infer the states from the actions. So each action will create an effect state, and initial or first actions will create initial states for the system. Those states are again parsed to be able to create state data, which have a name, an actor, the parameters, a time, a natural language description, and the features for the projection. Now the features, as I mentioned, can be made of any of the parameters of the action. And if you want to use a feature which is, say, position, the system will automatically try to extract the exact coordinate of the position using the roadmap data. So when we have the state data, we can use it for the time curves and the scene map visualization as well. So for the time curves, what we do is we project the states, and this is first done by computing the similarity of between states. We're using Gauss general similarity coefficient in our application, simply because it allows us to mix numerical features such as the position, and mix them with categorical features such as the actor type. We also provide the user with a means to adjust the weight of features, just to be able to give them the opportunity to explore specific dimensions if they want to. Once we have this similarity, we simply project it using a multi-dimensional scaling algorithm. So now we'll show you a quick demonstration of the tool, which is available at this address. So when you arrive on the website, you are shown with this page where you can load your files. And once you upload it, the system will automatically parse everything and generate the data. I should mention here really that any computation and calculation is done locally and nothing is sent to servers. So first we have the time curves, which are looking quite messy at the moment, but it's just because we haven't really adjusted the features yet. Say I'm not interested in valve yet, but I want to explore the time axis a bit more, so I will just put more weights there. Now I noticed that because the drones are down there, I noticed that this curve is flipped, so I will just flip it back, and now we'll have something we can more easily understand. We see that robots 1 and 2 here down there are following the same path at the beginning of the plan. And then maybe I want to see look at the drones, so I will increase the z-axis a bit more, and then I can see that the drones are lifting up at the beginning and then carrying out with their tasks. One thing I notice here is that drone 1 and 3 are getting really close together at some stage, and if I click on it, I will be confirmed that those states are happening at the same time. So it might be worth looking into that in more detail. Next, maybe I can look at the valve in a bit more detail, and if I increase that axis, I can see that the valves are worked on by the ground robots. Robot 2 and 3 are dealing with valves at the end of their mission, and then I've got robot 1, which is dealing with 4 valves throughout the plan. Next, there is the activity chart, which has the standard interactions. Really, we can drag and pan the temporal axis. We have the actions here, which we can explore. This is a movement action, which was subdivided into 4 movements using the path planning algorithm, hence giving more detailed movement data. Next, I have here the scene map, where it shows me the position of the robots. I can see the movement by dragging the time axis above. If I go to time curves, actually, I can also select this region of conflict between the 2 drones, and if I go down there, I can confirm that my suspicions were true and the drones are close together at this stage. And if I move along, I can see how they interact really. I can also see that indeed robot 1 and 2 are following one another at the beginning of the plan. So this is obviously a work in progress, and in the future we want to include more on this interface, more customization on, for example, for the path planning. We also want to do more integration with other tools. For example, there are online planners that we would like our online visualization tool to be able to communicate with. We're currently working on a live replanning interface, just a user plan interface really, where the user can query the plans, visualize them, inspect them, and possibly query changes to the plan as well. Finally, we know that the planner and domains do have state data internally, and we will want to integrate our interface with tools that can extract this data, and possibly even get dependency data between the actions and increase the explainability of our tool for users. Thank you very much for listening. You can send me an email if you have more queries about it. I've also put the address for the OCUB and Strategy Futures websites, so feel free to have a look. Thank you very much.